Okay, so so far we have talked about how to resolve vectors, which is the fancy name of saying, given the magnitude and direction, how do you extract the components out of it, right? So taking magnitude, direction, and getting the components out of it, right? And we've sort of shown you the long way, but let me show you a quick trick where you can do that in a quicker way. And here it goes, right? So if I have a vector like this, right, and I have my system, my coordinate frame of reference like that, whatever all you need to do, right? So if I know the magnitude of it, let's say the magnitude is m, like this, right? So just m for magnitude for this case, let's say. You know what? Let's use the correct symbols, right? So let's say this is A, right? The vector is A. So the magnitude, I'll just call it A without a vector sign. Remember, that's one shorthand as well. Right? I can just denote the magnitude. I can denote it like this, or if I'm lazy, I can do it like this. So I'll be a little bit lazy right now. I'll just denote that A. And let's say you know the angle over here is theta, whatever it is, right? We'll look at different cases in a second. So this part, this is the length, right? This length over here is AX, and this length over here is AY. Okay. How do you know which one is which? Now, because sine, cosine always have hypotenuse on the bottom, which means the thing that you want to solve is always the thing that is not given, right? Because our task is going to go from magnitude and direction to the components. So the thing that you want to solve is always on top of the sines and cosines. Did you notice that? And the thing on the bottom is always the magnitude, which is the given thing. So you always know the magnitude already. And the things that you don't know is that. So what that means is you will always have a formula that looks like this. The thing that you want to solve is the magnitude, right? It's the magnitude of it times either sine or cosine, like this. So I can already, the quick trick over here is you can immediately write down AX is the hypotenuse, right? The long one, times either sine or cosine theta. And AY is A times either sine or cosine theta. So now the only thing to leave with is to find out which one is sine, which one is cosine. You know that it's going to be one of them is sine, one of them is cosine, right? Now, the trick is to remember this: is cosine is the one that sandwiches the angle, right? So remember cosine. This is a trick, so there's no no understanding to it. The understanding is here, right? A trick is just a trick, so you can memorize this trick if you find it useful. Is that cosine is the one that always sandwiches. You can imagine like a cosine sandwich, right? That sandwiches the angle. So you look over here and see which one. So is it AX or AY that sandwiches the angle with A? Well, AX is the one that sort of sandwiches it. So AX is going to be the one with cosine, and the other one has to be sine. Okay, so you can immediately get these formulas here. Don't recite this out of just by memorization, but know where it comes from, right? And it saves you a lot of time, right? So I'll give you an example. Well, let's do this exact example over here. Get some space over here, right? Ignore this part. Let's see if our trick works. So over here, if I want, let's start with the one that is sandwiching it, right? I'm not even looking over here. So BX, I know it's going to be the magnitude, which is 12. And because it's sandwiching 30 degrees, so it's going to be cosine 30 degrees, right? And BY is the one that is not sandwiched. So not sandwiching the angle is the one opposite. It's always going to be sine because sine is opposite, right? Sine is opposite over hypotenuse. So it's going to be 12 sine 30 degrees, right? So I can immediately write this down without doing anything. I'm not even looking there, right? So now let's compare our answers and exactly, right? So I've done it exactly right. So this is a very quick way of doing it. However, be careful, right? Don't remember that x is always cosine, even though I made it look like so over here, because I can give you an example. Let's do it below over here. I'll give you an example that it's not that case, right? So don't memorize that x is cosine. Memorize that's the one sandwiching the angle is the one to use cosine. So for example, let's say I have a vector pointing here. Let's call this vector c, right? And c, the magnitude of c, let's say is 13, okay? So the length here is 13 and the angle here is 10 degrees, let's say, okay? So now you draw your lines that is perpendicular from the axis. Okay, where's the x and y component? Well, it's going this way, right? So this is cx, right? So that length over here is cx. This length over here is cy, like that. And yeah, okay, so let's see. So which one is the one? So this is c, right? This is the length c. This is cx, this is cy. So which one sandwiches the angle? Well, it's cy, right? So cy is going to be c times cosine 10 degrees. Okay. In our case, that's 13. C is 13. So I could directly, straightforwardly write that down. And cx is the one, if you think about it, although it's not obvious, right? If that is cx, this part is also cx. Right? Agree? So cx is the one that's opposite of 10 degrees. So that's going to be 13, right? So that length is 13 times sine 10 degrees. Okay. So as you can see, in this time, it's cy that is with cosine because I've drawn it. I've given the angle over here. But if I give you this angle, 80 degrees, then it will be cx that is cosine of 80. So I can equivalently write cx is 13, right? That's times cosine, because this time that's the one sandwiching, right? Sandwiching the 80 degrees, cosine 80 degrees, like this. Now I'll leave it up to you, right? You can do it right now. Plug these two in the calculator, and you'll see that you should get the exact same numbers, right? Try it right now, and you should get the exact same number. And in fact, it's always true, right? So sine of one number is always cosine of 90 minus that number. Okay, that's exactly how it works. Okay, yeah. So this is the quick way to go about it. And now that we know how to go between the geometric view and the algebraic view, let's see what's the benefit of algebraic view. And you'll see that the mathematics and the algebra becomes very, very easy, right? So we'll see that in a separate video.